In this video, we are going to learn about functions and graphs. We will try to determine if the function is even or odd. It says that even functions have y-axis symmetry. So showing the graph here. So for an even function, for every point of x and y on the graph, and the point negative x as well, and y is also on the graph. So therefore, this one is an even function. Odd function have origin symmetry. So what will happen to the even function? The original point is in x and y, but the result will go to quadrant number 3, which is negative x and negative y. So it says that for an odd function, for every point x and y in the graph, the point negative x and negative y is also on the graph. Okay, so we will not talk about function with x symmetry. Okay, so because it wouldn't be a function. Back in vertical line test, if you will take a line test there will be no we have function, because the vertical line test will process two different points. So a function is even if f of negative x equals to f of x for every number x in the domain. So there are given functions, and then if we are going to let the function f of x becomes negative x, but the result is still equal to f of x, therefore that is an even function. So if you plug negative x into the function and you get the same result, okay, the same result as the original, therefore that is even. So let's try to check. So for example, the function is f of x is equal to 5x to the power 4 minus 2x squared plus 1. And then what you're going to do to check if it is even or odd, you're going to change the function f of x into negative x. So therefore you change now the sign from a positive to a negative f of x. So therefore we have here 5 times negative x to the power 4 minus 2 times negative x squared plus 1. So even we have the even exponent. So therefore whatever you will multiply, the result is still positive, right? Negative times negative times negative times negative becomes a positive. So therefore the result will be 5x to the power 4 minus 2x squared plus 1. So you can see that this function is the same as our original equation. So therefore this function is even. But here in the second function, is it even? So when we are going to substitute now negative, so we have f negative x, so 2 negative x cubed minus negative x equals to negative 2x cubed plus x. So everything has changed. Therefore, this one is not an even function. Let's go to an odd function. The function is odd if we are going to substitute f of negative x will be equal to negative f of x for every number x is in the domain. Okay, so if you plug negative x into the function and you get negative of the function back again, all terms change sign, it is an odd function. So let's try to go back to this one. So therefore here we say this one is even, right? So this one is even function. But on the other hand, we have 5 or f of x equals to 2x cubed minus x. When we observe, everything of the sign changes. So therefore, this is an odd function. Okay? So again, if we are going to substitute f of negative x, and then the function will go back to its the same original sign, therefore that is even. But if all of the functions, all of the sign changes, that is an odd function. Now, if a function is not even or odd, we just say neither, meaning neither even or odd. how we will determine that one? There will be no changes, okay? There will be changes, but not all the sign changed and then did not go back to its original equation. So for example here, f of x is equals to 5x cubed minus 1. So the sign of negative 5, okay, from positive becomes negative, but the negative 1 there stays the same. So therefore, we have the neither, okay, neither result, because it did not change into a total form and then it did not go back to its original form. So therefore, your answer is neither even nor odd. How about the next one? F of x negative 3x to the power 4 minus x squared plus 2. What do you think? When you check here, f of negative x, it is even numbers, so therefore it will go back to its original we have function. So therefore the equation is an even function. Next, let's go back to our library of functions, meaning that we have what are the types of functions that we all know. We have the linear, quadratic, we have the absolute value, we have the zero of the slope, and then we have the square root of x. So let's see some of the functions. Okay, linear functions. So we have the positive linear and then we have the negative increasing, and this one is decreasing, increasing as well. So it will be formed of f of x is equals to y. We have f mx plus b, or we say that y is equals to mx plus b, where f of x is also equals to y. Okay, so next, constant, or the slope is 0. So therefore we will have now f of x is equals to 3, f of x is equals to negative 1, and f of x is equals to 1. So where b is all real numbers. So these are, we have the constant functions. So would it be constant function, be even, or odd, or neither? So the answer there will be an even function, because whatever you will do, it will return back to its original, right? Because there is no variable there. Next, identity. F of x is equals to x. So therefore, f of x is equals to x, the slope is 1, y-intercept is equals to 0. So therefore, it will be going to the origin, okay? So therefore, we will have now y is equals to x, right? 0, 0, we have 1, 1. If y is 1, x is 1. So therefore, they are equivalent, equal. The domain of this function is all real numbers, meaning from negative infinity going to positive infinity, the same as the range from negative infinity going to positive infinity. So it will be an odd function. Square, meaning it is quadratic function, or we say it is a parabolic, we have graph. So it is f of x is equals to x squared. The domain of this function is all real numbers, but here from negative infinity going to positive, but the range is just only from negative, we have 0, right? Because the origin of this one, x squared, is from 0 going to positive infinity, but it depends on the equation, okay? So therefore the range here, if the equation is f of x equals to x squared, the range is non-negative real numbers, which is from 0 going to positive infinity. Cube. What do you think about the cube? So therefore the cube is f of x equals to x cubed, and then the domain of this function is all real numbers, because the graph will go from negative infinity going to positive infinity, and also we have the value of y also is from negative infinity going to positive infinity. We have the value here is even. How about the square root? So if you will graph square root of a function, so we will let all the value of x be positive, because if it is negative, we have imaginary numbers, right? So square root function, y is equals to square root of x, or f of x equals to square root of x. The domain of this function is non-negative real numbers. So as what I've said, the domain is from 0 going to, we have positive infinity. The range as well is from 0 going to positive infinity. So this one, the result will be, the function will be neither odd or even. Reciprocal. So f of x is equals to 1 over x. So this one is the function of a reciprocal. So we have the domain of this function is an all non-zero because it's from x, right? So they will meet everything closer until closer to the value of, we have y, and closer to the value of x, but it will not cross x and y function. The range is all non-zero, so this one is an odd function. Absolute value. So absolute value of x. So the range is from negative infinity going to, the domain is from negative infinity going to positive infinity. The range is from 0 going to positive infinity. So therefore this one is an even function. So these are all the functions, okay? So please try to recall all the functions and how to find the domain and then the range of the functions and the graphs, okay? So that it's easy for you to remember how you will determine the domain and then the range. So how we will determine now the vertical shifting. The vertical shifting is in the value of, we have vertical line, right? The vertical line. So it's in y axis. So it will be upward or downward. Adding a constant to a function shifts its graph vertically. So for example, we have in general, suppose we know the graph is equals to y equals to fx, or y is equals to fx plus c, or y is equals to fx minus c. So plus c will going up, minus c will going down. Okay, so that is how you will determine the upward and downward. So here we will say that y is equals to fx plus c in c units above, and then if it is y is equals to fx minus c, it's going downward. So we obtain the graph of y is equals to fx plus c simply by shifting the graph of y is equals fc upward c units. So whatever the value of c there, that is the unit that you're going up. But if it is down, so it will be minus c. Okay, for example, original equation is y is equals to fx. If you're going to add plus c now, so therefore you're going up by c. That is the meaning of vertical shifting. Okay, so if the original equation is y is equals to fx, and then y is equals to fx plus c, so therefore you just add c. So therefore this is the new, we have graph, the same as in minus c. So it will be going down. So let's try to check how we will determine now the graph of each given functions. So g of x is equals to x squared. X squared is parabola plus 3. So therefore the origin now will not start from 0 because we have plus 3. So therefore here, okay, so from here, okay, the example going back, x squared plus 3. So the original equation is fx equals x squared. So this one is parabola. But we have plus 3 here. So therefore you're going up by 3 units, and this one now will be your origin. So therefore the graph will start there. Okay? And then the next part is, the second one is x squared minus 2. So therefore we have now the origin is from 0, okay, from 0 point here going down by 2 units. Okay, the other one is going up by 3 units. So therefore the graph will be this way. Okay, so therefore this is now the graph of x squared plus 3, x squared, and x squared minus 1. So how about horizontal shifting? Horizontal meaning horizontal line, right? Horizontal line. So it will go this way, right? So therefore, it will go inside of the function. So how do we use it to obtain the following graph. So it will give you f of x plus c and x minus c. Remember, in the vertical shifting, it is outside the function. So f of x plus c and then f of x minus c. But here it's inside the function. F of x plus c, or f of x plus c, f of x minus c. So that is how we will determine now the graph. But here, always remember, if it is f of x minus c, it will go to the right. But if it is x plus c, it will shifted to the left units. It's different from x plus c and then x minus c, right? If f of x plus c, it will go up. F of x minus c, it will go down. But if it is f of x minus c and f of x plus c, so therefore it will go, we have different shifting. So let's try. So it says that the original equation is f of x, and then the second equation will be f of x minus c, so therefore it will go to the right, and then f of x plus c, it will go to the left. Let's try some example. How about if we have f of x, or g of x, okay, g of x, x plus 4 squared. This will apply only the shifting in quadratic equation, okay? So f of x, so therefore we will go to the graph. So the original equation is x squared, but we have plus 4. So therefore, you move now the equation 4, we have points. And then if it is minus 2, you move the origin now plus 2. So that is how you will check now the equation or the graph. How will we know the opening of this one? How many we are going to put the points there? So just let the values of x, okay? So whatever the value of x, that will be the result for sure. So for example, if f of x is equals to, we have 1. So 1 plus 4, that is 5 squared, that is already 25. So therefore, if x is 1, therefore you will have now 25 values. Okay? Now, sketch the graph of f of x. It's a combination now of x squared of x minus 3 plus 4. But the problem here is, or you can start the graph by graphing y is equals to square root of x. The y squared of x is, this is the graph. You can see this is a shifting plus 4, okay? X minus 3 is shifting horizontal, and then we have plus 4 as well. So therefore, your graph is from here and then going up there. So this one now will be the graph of square root of x minus 3 plus 4. Okay, so here guys, just only sketch the graph. I think some of the textbook, it will not show the exact graph, just only the origin of the graph, where the origin will start. So from here, from the original equation, which is square root of x, okay, so it will shift x minus, we have x minus 3, which is going to the right, and then plus 4 going up. So that is how you will determine now the shifting of horizontal and vertical in every graph. Reflecting graphs. Reflecting graphs is, I already shown some of the example, this one, if it is negative, right? So y is equals to negative f of x, and y is equals to f of negative x. Okay, so how we were supposed to do that one? So the y coordinate of each point of the graph of y negative f of x is simply the negative of the y coordinate of the corresponding point of the graph of y is equals to fx. So the desired graph is the reflection of the graph of y is equals to f of x in the axis, okay, x-axis. So let's try to show the graph. So here, so y is equals to f of x. The reflecting graph is y is equals to negative f of x. The other one, y is equals to f of x, and then y is equals to f of negative x. So that is the reflection. The blue is the original one, and then the pink color is the reflection of the original graph or function. So let's say we have y is equals to negative x squared and y is equals to negative square root of x. So x squared, the blue one, and then negative x squared is the reflection of x squared, right? So therefore that is how you will determine the next one. Square root of x and then square root of negative x. So they will be reflecting each other. So this is now how you will know if the graph will reflect to each of the following function. Okay, so how to determine that one? Just put any of the following. We have domain. Okay, so you write negative, so therefore you can get the result, right? So whatever the result there, so we'll say 0. So 0. If x is negative 1, so therefore you have, that is 2, right? So therefore you will move there. So the same as the function inside the square. It will not be undefined because negative times negative becomes a positive result, right? So therefore it will go up this way. Vertical stretching and shrinking. Okay, so this one. Suppose we know the graph of y is equals to fx. How do we use it to obtain the graph of y if c fx? So there will be a value of fx inside. So the y coordinate of y is equals to c fx, and x is the same as the corresponding y coordinate of y is equals to fx multiplied by c. So let's try to go directly to the example so that we can explain further. Okay. So example, we have the original equation. We have y is equals to fx. If you will multiply, if c is greater than 1, it will go up. Okay? And then if c is less than 1, it will go down. Okay? Big opening of the graph. But if it is less than negative, or it is less than 1, it will be closer, it will be smaller. We have curve. Okay, so let's try to do some examples. For example, here we have 3x squared and then 1/3 x squared. So therefore, when we are going to graph that, so the original equation is here. Okay, so we have this one is the x squared. If we have value of x squared there, so it says c times x squared, right? So therefore we have 3. So it will be closer to, the parabola will be closer to y. But if it is 1/3, the opening of the parabola becomes wider. Okay? So if it is greater than 1, the parabola will be closer to y. If we have less than 1, the opening of the parabola will become wider. Okay, so that is how you will determine now if it is vertical shrinking of the parabola. Okay, so vertically it will shrink, or it will be closer to, we have the value of y. Okay, the opening will be smaller and the opening will be wider. Okay, let's try this one. Sketch the graph of the function 1. Okay, f of x is equals to 1 minus 2 times x minus 3 squared. So we will try to illustrate the combination of shift, reflection, and stretching. So we have here the x squared. Okay, so the graph is x minus 3. So therefore, it is x minus 3. So it will go positive 3 here. Okay, and then, but we have the function negative 2. Okay, so therefore we will have now as negative 2. Okay, here, right? We have negative 2 there. So therefore this one is the blue. But it says that f of x is 1 minus 2 times x minus 3. Okay, 1. So therefore it will shift. Okay, so it will shift to the right, and then it will go up by 1. So here, the 1 here, the 1, and then this shift. Okay, so again, original equation x squared, and then we have x minus 3. So x minus 3 will going to the right by 3 units, right? So therefore this one now, and then after that, next one is we have it's negative. So therefore, it will reflect the x squared. And then we have positive 1 here. So therefore, it will go up by 1. So the negative 2 here is for the reflection of the graph. The reflection of x squared. It's not included to 1 here. So therefore, you will have now the graph is this pink one. So this is now the origin is 3 and 1. So which is 3 and positive 1. And then it's negative 2x negative. And then we will have this equation, or we have now this graph. So therefore, the graph of 1 minus 2x, or 2 times x minus 3 squared, is the pink one. So we all know already about how we will do the shifting, the stretching, and then the reflecting. The last one is the horizontal shifting and shrinking. So it will give you the f of cx. It's inside now of the function. Okay, so let's just go into the example. Okay, so the original f of x, and then it will, the curve now is smaller, right? It's longer, but its opening is shorter, and then the other one, it's wider. Okay, the opening is wider. So let's go to the example. Okay, so it says that y is equals to f and 2x. So this one is not a parabola, right? Because this one is just only function f of x. Okay, so f of 2x. So sketch the graph. So therefore, we will have now as the function equal to this one. So this will be the graph of that equation. And then if it is 1/2, so that is the difference between the two. If it is 1/2, it will open wider. Okay, and then if it is 2, it will be smaller wave. Okay, so using the principle described earlier, we obtained that the graph looks like this one. So if we have questions and clarifications of our lesson, you can send an email and you can ask. So we have to practice more on how to determine the function, if it is even, if it is odd. Okay, the stretching, the shrinking, we have the shifting, horizontal shift, and vertical shifting. That is all for our lesson. Thank you so much and have a nice day.